Guys, there we go. Can I get a thumbs up that you hear me and see the board okay? Okay, I'm gonna start today by finishing the last two examples from yesterday's notes, just to go over questions like this, because they will be on the homework for today's problems. All right, so now that we have all these log properties, there's one more property that I'll do in today's notes after these, but now that we have all these properties, now there's little things that we can do to rewrite expressions with logs. They're gonna help us when we solve the log equations in the next chapter. So if you look at this expression right here, you're asked to simplify it. Well, guys, I do notice that I have a base 6 exponential raised to a very weird exponent, all right? But in that exponent, I definitely see that I have logs base 6, which is great because I know base 6 exponentials and logs base 6 will undo one another. However, it can't undo this and this over that addition. However, if I have two base 6 logs that are separated by addition, I can put those back together to being one base 6 logs using multiplication. So I can rewrite this as 6 to the log base 6 of, put these two logs back together, doing 3 times 5, which is 15. Now that you've created one base 6 exponential and one log base 6, now what do they do to each other? They cancel, and you're just left with 15. Okay? All right, now this one, I think they put a problem like this right after it because they want you to kind of think this, which we are going to. But the problem is, I have a base 10 exponential raised again to a very weird exponent. I do notice that I do have a log in this exponent, and anytime I see a log without a base, it's assumed to be 10. So I do have a base 10 exponential and a base 10 log. The problem is I need to get that log condensed back to 1. But this isn't a log. Yes, this and this are separated by addition, but he's not a log. So there's a couple different ways you can do this problem. I always think of it like this. I have 10 raised to this power. This is an exponent. So guys, clearly I've added two exponents together. I have this exponent 1 plus that exponent 2. What operation in math would have made you add two exponents together? Think about it. If we had 10 to the second times 10 to the third, that's the same base. I'm multiplying. That's the same thing as 10 to the 2 plus 3. I would have added my exponents, and it would be 10 to the fifth. So it's the same thing here. If I added this exponent with that exponent, then I must have been multiplying base 10 exponentials. So I can rewrite this as 10 to the first exponent, times 10 to the next exponent, 2 log 5. I can definitely do that because what would I do now if I'm multiplying two base 10 exponentials? I would add their exponents and it would become 10 to the 1 plus 2 times log 5. So guys, 10 to the first is 10. I can throw this 2 back up as an exponent, and now it's 10 to the log of 5 squared. Well, guys, what does a base 10 exponential and a log base 10 do? They cancel, and you're left with 5 squared. So this is 10 times 5 squared, which is 10 times 25, and you get 250. So they're really going to put your manipulation skills to the test. Now that you have all of these log properties and these exponent properties, can you use them to manipulate math problems to simplify it down to a final answer? All right. Another way you could have done this problem, just while we're here, guys, think about this. If I had two log 10s that were being added together like this one, I could have put them back using multiplication. So guys, if that's 1, you could have rewritten this as 10 to get 1. Guys, isn't that the log of 10? Isn't the log of 10 1? Yeah, 10 to what power is 10? 1. So you could rewrite 1 as log 10 and then plus 2 times the log of 5. And now you'd be able to condense these two base 10 logs back together as one log using multiplication. Just throw that back up, and now you have 10 to the log 10 plus log of 5 squared. Put them back together, that's 10 to the log of 10 times 5 squared. And now guess what? Your base 10 exponential and your log base 10 cancel, and you're left with 10 times 5 squared, which is 10 times 25, which is 250. So lots of different things we're able to do now using these logs in order to manipulate math problems, okay? All right, so those were the final two problems off of yesterday's notes. Now I'm going to go to today's notes, which is the last property of logs, and it's the change of base formula.
Can you keep up those two problems that you just wrote?
Yep.
Thank you.
Can I get rid of that?
Yeah.
Okay. All right, so guys, let me give you a couple calculator problems real quick, just so you are aware. You guys are a very, very spoiled generation in the fact that you have a graphing calculator. And this graphing calculator, it's like almost limitless in what it can do. It does so much for us in math that I didn't have this ability. I didn't learn with a graphing calculator. They were really big when I was in high school. So the calculators that we used were just the normal scientific calculators. Well, guys, a normal scientific calculator, not a graphing calculator, it's only programmed to be able to find the answer to a base 10 log or a base e, the natural log. It doesn't find the answer to a log base 2 or a log base 3 or a log base 4. It's not programmed to do it. Scientific calculators were only programmed to be able to evaluate base 10 or base e logs. But these scientific ones, not scientific, these graphing calculators, guys, they evaluate any base log. It's awesome. So to have the change of base formula, you guys would argue, well, why do I need to change the base? This calculator can find the log of any base. So yeah, you kind of have a point. But there might be problems out there, equations out there, where we do need to change the base of the log to a different base. So we still have a need for the formula, but when it comes to answering questions like this anymore, oh my God, you guys are spoiled. Your graphing calculator will tell you the answer without ever needing to change the base to a base 10 or a base e. So just to show you how your calculator works, in case you haven't figured it out already, if I wanted to find log base 3 of 41, we used to have to change that to either base 10 or base e so our calculator could do it. Your calculator will answer that right now. But guys, you can reason it out. 3 to the third is 27. 3 to the fourth is 81. So when they ask you what's log base 3 of 41, they're asking you 3 to what power is 41? Well, 41 is somewhere in between 27 and 81. So clearly it's some decimal. It's 3 to the 3 point something. We know that, but 3 point what? Do I have to raise 3 to get 41 as my answer? So guys, your graphing calculator will answer this. There's two ways that I know how to do it. Maybe there's more. So I don't know if I can do this on camera, but on your screen, guys, I have a log button over here. So if I just hit the log button, that means, I can't get this to focus. That means it's a base 10 log. Clearly this is log base 3. But if you do this, if you do log 41, oh, I didn't hit 41, I hit 47, and then comma, your comma, then put a base of 3. So if you do log 41, comma 3, I can't get it to focus. It'll do log base 3 of 41. Hit enter, and it's about 3 point, I can't read it, my camera's going crazy now, 3.3802. So again, if you just hit log 41, comma 3, it's going to take the log of 41 with a base of 3. Your graphing calculator is programmed to do that. Like I said, a normal, just scientific calculator wouldn't be able to do a base 3 log. The other way your calculator can do this is if you go to the math button, mine is right here, the math button, and if you scroll down to the letter A, I believe, you guys actually have a log base option. So if you get that, if you hit log base, then this pops up and you're physically able to put in a base and a number. So I would do base 3, right arrow over to 41, hit enter, and you get the 3.3802 that way. So you have this option and you have the log base button, which is under the math key. So that's two ways that your graphing calculator will answer that question for you. Like I said, before we use the graphing calculator, you'd have to switch this log to either a base 10 log or a base E log, so then your calculator could find out the answer. All right, if I want to know log base 7 of 19, well, guys, I know 7 to the first is 7. I know 7 squared is 49. 19 somewhere in the middle, so I know it's going to be 7 to the 1 point something, but what point what? 7 to what power gets me an answer of 19? Well, we have the luxury of asking our graphing calculator. I'm just going to do log 19, 7. Hit enter, and it's about 1.5131. All right, so thumbs up if you're okay with the calculator. Everybody all right? Excellent. Okay. All right, so guys, there is going to be, oh, go ahead, Michael, do you have a question?
I'm sorry, I can't read what it says next to log under like the log.
This says log 41, 3, and this says the math key to the log base button. I was just showing you the keys on your calculator.
All right, thank you.
You're welcome. All right, there's going to be a formula that says you can take any base log, any base it is, and you can rewrite it in a different base. Normally, the bases we choose are base 10 or base 8, because those are the ones that all calculators can handle. So normally we would take like a base 2 log and rewrite it as a base 10 or a base E. I'm going to try to train you guys to go to base E, the natural log. The natural log is much more user-friendly in calculus, so I do kind of want to get you on that natural log train, all right? But I'm going to come back to the formula. Guys, look at this. If I asked you guys right now, what's log base 2 of 8? Everybody knows that answer without ever looking at a calculator. It's asking you 2 to what power gets you 8? 2 to what power gets you 8? We all know the answer to that is 3. The answer is 3. X has to be 3. That's the power that I have to raise 2 to get 8 as my answer. But if I asked you guys what's log base 2 of 9, right? Without a graphing calculator, 2 to what unknown power is going to get me 9? So 2 to what power gets me 9? So in answering that, guys, you guys have the luxury right now with these graphing calculators where you could be like, all right, that's a base 2 exponential. I'll take the log base 2 of both sides because a log base 2 will undo a base 2 exponential. And now x will equal log base 2 of 9, which is right back to where we started. You guys can ask your calculator, what is that? Let's do it right now. What is log base 2 of 9? 2 to what power is 9? It's probably 3 point something, right? So log 9, 2. It's 3.1699. The answer to this is 3.1699-ish. Okay. But guys, what if we didn't have this calculator? What if our calculators were like before and they were unable to compute a base 2 log? They'd only be able to do a base 10 or a base E. How would we handle the problem then? So guys, let me come over here. Go back to this part right here. Go back to the 2 to what power is 9. I wouldn't want to take the log base 2 of both sides if it's an operation that my calculator couldn't handle. So what we used to do in a situation like this, I know my answer is a missing exponent. And guys, who finds exponents for us? Logs. That's log's jobs. They find missing powers. So instead of taking log base 2 of both sides, because that used to be a log that our calculator couldn't handle, we would just take the log of both sides. All right? So log both sides. Not log base 2, just log both sides. Or it could be natural log, because that's another base our calculator can handle. So now what happens? Nothing cancels. This is a base 10 log and a base 2 exponential. They don't cancel. I literally get left with the log of 2 to the x equals the log of 9. However, what I've done now, by creating this log, this unknown exponent of mine, I can now drop down in front as a factor, and he's no longer in the actual logarithm anymore. So now it's going to be x times log base 2, and it equals, not log base 2, log 2, and it equals log 9. So now the only thing I have to do to find out what this missing power was is divide the log 2 away. So now my missing exponent, x, is equal to the log of 9 divided by the log of 2. And guys, these are logs that any calculator could find. These are base 10 logs. So I've literally taken a base 2 logarithm, because remember, that's who x was. X is log base 2 of 9. It's actually equal to the log of 9 divided by the log of 2. So I have rewritten a base 2 log as the quotient of 2 base 10 logs. And now this is something that any calculator could answer. So guys, we already said log base 2 of 9, it's about 3.1699. Ask your calculator, what's log 9 divided by log 2? Guess what? It's the same thing, because you are able to rewrite a base 2 log as the quotient of 2 base 10 logs. So if you ask your calculator what's log 9, close the parenthesis though, divided by log 2, you get, again, 3.1699. It's the exact same answer, because log base 2 of 9 is equal to the quotient of 2 better base 10 logarithms. So guys, that's the change of base formula. So if you look what we did, look what happened. Log base 2 of 9 became the log of a better base, a base 10 log of 9, the number you were originally taking the log of, divided by log with a better base of 10 of the actual old base 2. So that's the formula to change the base. So the change of base formula says, if you have log, let's say base A of M, where A equals a bad base. A bad base is not 10, it's not E, because we don't want any other base that our calculator can't use. It's going to equal, according to this, it'll be the log with a better base. We'll call that base B, where B is a better base. And if it's a better base, guys, it's 10 or E. That's your better basis, because all calculators can compute base 10 or base E logs. All right? So it's going to be log better base of who you were originally taking the log of, which was M, divided by the log with your better base B of who your old base was, N. So that's the change of base formula. You can rewrite any base log into the quotient of log better base of M divided by log better base of A, your old original base. And we can use this now. We can use it to manipulate problems. Now I can take any logarithm in any base and I can rewrite it with a different base. All right, let's try some. And guys, I do want to show you really quick. You do not have to write this down. We had 2 to the x is 9, right? 2 to what power is 9? I told you guys to log both sides. You are allowed to natural log both sides as well, because the natural log is considered to be a better base too. So then you end up with the natural log of 2 to the x equals the natural log of 9. Drop down the x times the natural log of 2 equals the natural log of 9. To find out that missing power again, you divide, and x ends up being the natural log of 9 divided by the natural log of 2. So remember, it became the log of a better base of 9 divided by the log of a better base of 2, your old base. And guys, if you ask your calculator what's the natural log of 9 divided by the natural log of 2, it's also 3.1699. It's the same answer. So you can log both sides, or you can natural log both sides. Make it a base 10 or make it a base E. I'm going to try and train you guys to go the natural log route, the base E, because it's just more user-friendly in calculus. All right, here we go. Now we can go to all right, so the directions say, approximate using the change of base. Round your answer to the nearest thousandth. Guys, I know Log base 5 of 89. I understand. You guys can plug that into your calculator right now and get the answer because you have a graphing calculator. Let's pretend you didn't. Let's say you had to rewrite this with a better base, a base 10 or a base E. So guys, what would it become? It says it's going to become the log better base 10 of 89 divided by the log better base 10 of your old base 5. That's what the change of base formula says. It becomes the log with a better base of 89 divided by the log with your better base of 5, your old base. Or you could have went natural log. You could have went the natural log better base of 89 divided by the natural log of your old base 5. Either one of them is going to get you the exact same answer. So now ask your calculator, what's the log of 89 divided by the log of 5? Or what's the natural log of 89 divided by the natural log of 5? Every single one of these is going to get you the exact same answer because they're all equivalent. Log 89 divided by the log of 5 or the natural log, whichever ones you're hitting, and it's about 2.7889. What did I say, thousand? 2.790. If we round to the nearest thousand. All right, and again, whether you go right to the button on your calculator, whether you change the base to 10, or whether you change the base to E, all of these get you the same exact missing exponent. All right, guys, what if you were asked to take log base 3 of 75? Let's change the base, right? Let's get used to using this change of base formula because it's another way we can manipulate things. All right, I could rewrite this. Let's say we write it as a base 10 log. As a base 10 log, it would be log better base 10 of 75 divided by log better base 10 of your old base 3. That's what the change of base is. This becomes this as a base 10 log. Or if I wanted to make it a base E log, then I could make it the natural log base E of 75 divided by the natural log better base E of my old base 3. Either one is going to get you the exact same answer. All right, so if you ask, I'll do natural log this time. The natural log of 75 divided by the natural log of 3. The answer is 3.930. And you're good to go. And then again, if you even double check, ask your graphing calculator, what's log base 3 of 75? It's going to give you the exact same answer because this, and that are all the same thing. All right, I'm going to give you guys write that one. In change of base, what does it become? Either write it as a base 10 log or a base E log.
Go
ahead, Michael.
What was it said like log A M E.
A is your bad base, the base you don't want, the original base, and B is your better base, being base 10 or base E.
What was in the denominator of the right section of that? I'm sorry.
Change of base is log base A of M equals log base B, a better base 10 base E of M, divided by log base B of A, your old base.
Oh, okay.
So B is your new base, usually 10 or E, and then you take the log of what you originally took the log of first, and then the bottom is the log with your better base of your old base.
All right, thank you. I just didn't catch the bottom part.
Yep, you're fine. All right, so here, log base square root of 2 of the square root of 5. So I would rewrite this as a log base 10. It would be log better base 10 of the square root of 5 divided by log better base 10 of my old base, the square root of 2. Or I could rewrite it as a base E log, which would be the natural log base E better of the square root of 5 divided by the natural log better base E of my old base, the square root of 2. All of that gets you the exact same answer. I think it's like 1.5 something. Oh, I don't know what I'm thinking of. 2.3219. I should say 2 because we're rounding to the thousandth. Okay? All right, give me a thumbs up if you can confidently change a bad base log to a better base log. Everybody okay with the formula? Okay. Yes, go ahead. Oh, I thought somebody had a question. Okay. All right, then watch this one. Look at example 2. Simplify this expression. They want you to give an exact answer, which means you can't start asking your calculator to do it. They want an exact answer. You ask your calculator what's log base 6 of 2, it's going to give you a decimal. We don't want decimals. We want exact answers. All right, so guys, look at this problem. Log base 2 of 6, which again, does anybody know 2 to what power is 6? No, it's a decimal. We don't want to do that. We don't want to ask the calculator what that is. And then log base 6 of 8, right? Well, I don't know 6 to what power is 8 either. So right now I have a base 6 and a base 2 log, none of which I can actually answer without my calculator. And I don't want to do that. So right now, maybe converting these two different base logarithms to a same base log will get us somewhere. So you can either convert them to natural logs or you can convert them to logs. It doesn't matter. So just to stick with this one, if you guys convert this to a better base log, I could rewrite this as log base 10 of 6 divided by log base 10 of 2. Or guys, I could have went this route. The natural log base e of 6 over the natural log base e of 2. I could have went to a log or I could have went to a natural log. It doesn't matter. All right, times, let's convert this to a base 10 log. So now it becomes the log base 10 of 8 divided by the log base 10 of my old base 6. Well, right away, or again, I'm doing it with a log and a natural log, I could have done the natural log of 8 divided by the natural log of 6. Guys, this and this cancel now, and so do this. So I'm left with the log of 8 divided by the log of 2. Or if you went the natural log route, you'd be left with the natural log of 8 divided by the natural log of 2. Your logs and stuff can't cancel, but guys, this is a base 2 number. I can rewrite 8 as a base 2. I can rewrite this as the log of 2 to the third divided by the log of 2. Now, this exponent can drop down in front and become 3 times the log of 2 divided by the log of 2. And now, my log 2's divide out of the problem, and 3 is my final answer. So they just expect you to be able to look at problems and know how you can manipulate it. Exponents go hand in hand with logs. So if you can rewrite anything with the same base and an exponent, you're going to want to do that. All right, same thing. This would have been the natural log of 2 to the third. The 3 would have dropped down. The natural logs of 2 would have divided out. You still would have gotten 3 as your answer. All right, guys, this one, just before the bell cuts me off. Start rewriting everything. What's up? Oh, yeah. If you look at this problem, I would rewrite look at all these different bases. Base 2, base 24, base 26, base 20. Rewrite everything as the same base. Base 10, base 8. Guys, this becomes the log of 24 over the log of 2 times. This becomes the log of 26 over the log of 24. You're going to get all these cancellations because bases and answers are all intertwined. So if you do this one out, you're going to get all these things to cancel, and you're going to be left with a very similar problem to this. So I'm going to ask you guys to try that one at the end, if you guys can try and get it, but you should get a lot of stuff canceling once you rewrite all of them in the same base log. And then the problem ends just like this one. And I'll fill it in on your notes. All right? All right, if anybody has any questions, let me know. Again, the answer to this one will be on your filled in notes. Just try it. Watch all the cancellation that happens. All right, let me just check the attendance.